When we talk about angular velocity and angular acceleration, so you guys understood the difference between linear velocity and angular velocity. Linear acceleration, angular acceleration, right? So same way, the next physical quantity what you guys are learning is momentum. Okay, just like we have linear momentum, we also have angular momentum. Okay, so how we define angular momentum is the angular momentum of a particle about an axis is the moment of linear momentum about that axis. Okay, so let me explain what this is. You have a particle, okay, and then it rotates about a particular axis. So that has certain momentum, that is basically the angular momentum. Correct? Okay, so let's see how it goes. See, let's say the particle has some radius, let's say AB. Okay, so this is the radius. Now, the particle has to have certain, let's say, momentum. Correct? So, which is this, as you can see, this one. Okay. Now, see, it's making certain angle, right? So, how do we get to know what angle is this making? See here, we have, so draw AC and then you join BC. So, if you look at this, angle ABC is theta, correct? See, if ABC is theta, well, vertically opposite angle, even that will also be theta, correct? Okay. Now, see, we have R and then we have P. P is basically the linear momentum. Okay, the particle is moving. So, here we have to calculate what is the angular momentum of the particle, right? So, let's go through the normal derivation part. Okay, so what we have, see, we have triangle ABC. Now, what is sine theta in that? Sine theta is AC divided by AB, correct? So, AC can be written as AB sine theta, correct? So, why are we doing this? Because, so the angular momentum is what? About the axis it rotates, correct? So, how do we get to know the distance? That's basically the sine component, right? So, what we get is AC sine theta, which is R sine theta, correct? So, the angular momentum L is equal to P into R sine theta. Okay, so P into R sine theta. In other words, we can also write this in vector form, which is L is equal to R cross P. Since radius is a vector and even the linear momentum is a vector, angular momentum is also a vector quantity. Now, since it's a cross product, remember the rule of cross product. If you have two vectors and if you're taking the cross product, then the resultant will be in the plane perpendicular to both of them, correct? Same thing happens even in angular momentum also. Okay, whichever the plane, the radius and the linear momentum is, the angular momentum is perpendicular to both the planes. Okay, so since we have L is equal to R cross P, we need to look at the SI unit, right? So SI unit is kg meter square per second. Okay, so this is the SI unit of angular momentum. Now, we learned about, see, a lot of circular motion we are learning, correct? Rotational motion basically, like angular velocity, angular acceleration, angular momentum, all these things. Now, there is one more very, very important thing, torque. Okay, so torque plays a very important part. What is torque and how we derive the expression for torque, we'll see in the next video.